Hello, my name is Maria and today I will show you how to get state space representation of linear differential equation. So we have this equation right here, which is the fourth order derivative of y plus y is equal to 5u, and also we are given those state variables. Okay, so to start, we can write those state variables in this form. This is equal, but I think in this form it's more clear because we need to rewrite those variables by putting all of the y's and its derivatives on the left side and the rest on the right. So when our x1 is equal to 5y, we need to write this in this form that y is equal to 1 over 5x1, x2 is equal to 6 second order derivative of y, so this one is equal, the second order derivative is equal to 1 over 6 x2, etc, etc. It's quite simple here. So when we have all of our state variables in their new form, we should rewrite our main equation by putting the biggest derivative that is of the fourth order on the left side and the rest on the right here. So the fourth order derivative of y is equal to minus y plus 5u, and now we can substitute our y with state variables. So we are looking for the y is here, and we can see that y is equal to 1 over 5x1. So we are just putting y over x1 with the minus, of course, because here is minus, plus 5u. Now, when we have our main equation in its new form, we can move on to derivatives of our state variables. So to focus on the first one, on the derivative of x1, we need to look first for the just x1, for the plain x1. Sorry for this dot here, it shouldn't be here, it's my mistake. So we can see that x1 is equal to 5y. So just simply the derivative of x1 will be equal to 5 derivative of y. Yeah, just putting dot here. And I have this right here. So when we have the derivative of x1, we need to substitute y with the x's. So we are just looking for the derivative of y right here. And we can see that derivative of y is equal to 1 over 8x4. So we will substitute derivative of y right here. We need to multiply by 5 because its coefficient is 5. And by multiplying by 5, we get 5 over 8x4. Moving on to the second state derivative, we can see that the x2 is equal to 6, the second derivative of y. So the derivative of x2 will be equal to 6, the third order derivative of y. So we just simply put another dot here, just like here. So now we look for the third order derivative of y, which is here, and we substitute right here. So it's 6 times 1 over 7x3, and it's equal to 6 over 7x3. Now, x3, derivative of x3. Once again, we are looking for the plane x3, and we can see that it's equal to 7, the third order derivative of y. So the derivative of x3 will be equal to 7, the fourth order derivative of y. And we get the fourth order derivative of y from here. So once again, we substitute that, and we have 7 times all of this, and it's equal to minus 7 over 5x1 plus 35u. And the last one, x4. Once again, plane x4 is equal to 8 derivative of y. So derivative of x4 will be equal to 8, the second order derivative of y. The second order derivative of y is equal to 1 over 6x2. So once again, we substitute that, and we get 8 times 1 over 6x2, and it's equal to 8 over 6 x2. Now we can move on to our state equation, which is equal to that, ax plus bu, where A and B are matrices, and A is the matrix of the size 4 by 4. Why 4? Because our biggest derivative is of the order for the 4 dots here. So, to fill our matrix, we need to look up for our derivatives, x derivatives, and we can see that this one is equal to 5 over 8 x4. We don't have any x1, x2, or x3. We only have x4 and its coefficients. So, as I write here, we just leave x1, x2, and x3 for the zeros, and we put the coefficient of x4, so it's 5 over 8. The same for the second row. We only have x3, so this one will be 0, 0, 6 over 7, the coefficient of x3, and 0. The third row will be only minus 7 over 5, its coefficient of x1, and the rest will be 0. We will just ignore this one because we are looking only for the x variables, not for the u. And the last row will be equal to 0, 8 over 6, because I only have x2, 0, and 0. The B matrix will look like this, because we only have u on the third row. We don't have any use here, here, and here. So this one will be 0, 0, 35, and 0. And moving on to our output equation, which is equal to cx plus du. We need to look for the y, and we can see that y without any dots is only on here with x near the x1. So on the first place we put its coefficients, and for the rest we are putting 0 because we have only y here. And the d will be null because we don't have any use near y's. So that's all. Thank you for your attention.